The Milky Way Galaxy with Joe Pesce, astrophysicist at the National Science Foundation.
Hello and welcome back to the Cosmic Companion. Thousands of centuries ago on the ancient plains of Africa, our most distant hominid ancestor looked upward, embracing the pitch-dark night sky above their heads. Cultures around the globe made up stories of a bright band of light which ran across the inky darkness. Little could any person imagine the Milky Way was composed of hundreds of billions of stars, let alone comprehending the notion of a trillion galaxies permeating throughout the cosmos. Later on in the show, we're going to talk with Dr. Joe Pesce, astrophysicist at the National Science Foundation, talking about the supermassive black hole at the center of the Milky Way. Now, in 1610, the same year that Henry Hudson became the first European to see Hudson Bay, what a coincidence, right?
Go Henry.
Astronomer Galileo Galilei pointed his telescope toward the Milky Way. In doing so, he became the first person to clearly see individual stars within this diffuse band of light.
Go Galileo.
For centuries, we believed the stars of the Milky Way held the entirety of everything in the universe. Now, the Andromeda Galaxy, the nearest large galaxy to the Milky Way, is visible with the naked eye. In fact, it is the most distant object which can be seen by humans without a telescope. However, this blurry patch of light in the night sky was long thought to be a local nebula of gas and dust. Now, in 1920, the New York Times lambasted rocket pioneer Robert Goddard, saying he seems to lack the knowledge ladled out daily in high schools. Undeterred by such sentiment from an anonymous columnist, science somehow trudged forward that same year with the Great Debate. This contest of ideas between Harlow Shapley and Heber Curtis pondered the nature of spiral nebula, like Andromeda seen in space. Shapley held on to the old school notion, believing that these bodies were fairly small, lying within the Milky Way. Curtis argued that spiral galaxies were instead island universes like our own galaxy. Spoiler alert, Curtis was right.
Go Hebert.
Today, we know galaxies come in a wide variety of shapes and sizes. One thing nearly every galaxy has in common, though, is found near its core, a supermassive black hole. Sagittarius A star, the body near the center of the Milky Way, holds on to more than 4 million times as much mass as our sun. Recently, astronomers using the Event Horizon Telescope, a global network of radio telescopes, imaged Sag A star in detail for the first time ever. We talk with Dr. Joe Pesce, astrophysicist at the National Science Foundation, about this exciting new look at our local supermassive black hole. This week on the Cosmic Companion, we're delighted to be joined by Joe Pesce. He is an astrophysicist at the National Science Foundation and specializes in studying supermassive black holes, just like that one at the center of our own Milky Way. Welcome to the show, Joe.
Thank you. Thank you for having me. I'm very honored to be here with you.
Thank you so much. So for those who may be new to the subject, can you just give us a general look at Sagittarius A star, the black hole at the center of our Milky Way, and what makes it so cool?
So not unique, and this is the fun part of black holes, that we've learned over the decades that these so-called supermassive black holes, to distinguish them from the stellar-sized black holes that are much less massive, the supermassive black holes appear to be found in the centers of every galaxy. Wherever we look, we find these big monster black holes. And they range in millions of times the mass of the sun. Ours is on the small end. It's about 4 million times as massive as the sun, and all the way up to billions of times the mass of the sun. Now, the one in Sagittarius A star, the one in the middle of our galaxy, is special because it's ours. And more than that, we've been studying it. It's one of the few supermassive black holes that we can hope to be able to image directly. And in fact, we did that. And so last week, those observations were released. And I think that's, in addition to, our personal black hole, this is one of the few that we can hope to be able to see up close and personally.
Looking deep into the universe, we see backwards in time. And the oldest light in the universe holds secrets to how everything around us will, one day, end. Meanwhile, stars, planets, and galaxies dance in an intricate ballet, occasionally giving birth to life. We are a fledgling species, just beginning to visit other worlds. We are a way for the universe to understand itself. The Cosmic Companion strives to bring the universe down to Earth, and we depend on your help to make it happen. For information on subscriptions and ways to donate to this program, please visit thecosmiccompanion.net. Thank you.
And as you mentioned, of course, it's absolutely, everyone was recently, a few weeks ago by the time this airs, was delighted by, new images taken by the Earth Horizon Telescope as well as associated observatories. So what makes this finding so important?
Well, so fundamentally, black holes are enigmatic objects, and they're very difficult to observe for the reason that they are called black holes. They absorb everything, including photons of light, and so, light that falls in doesn't escape. So by definition, we cannot see them. And in fact, this observation, we're not observing the black hole because, again, by definition, we can't. We're observing the shadow of the black hole on its near environment. So number one, this observation is important because it's giving us new insight into black holes. It's allowing us to confirm directly that there is a black hole, in this case, Sagittarius A star. We've long known about black holes. Well, we've known about black holes for over 100 years, theoretically, from the time of Einstein, of course. And in the last, 50 or 60 years, we have strong evidence that they exist, but that's always been indirect. And so this observation, and the one in 2019 of the supermassive black hole in the galaxy called M87, this is the first time that we've been able to image that region near the black hole directly. And it's allowing us to prove that our understanding of black holes is pretty good, and we've been right all along, and Einstein has been correct. So the objects themselves, studying more directly the object themselves, because they are one of these mysterious objects in nature, in astronomy. They're important because they may form the nucleus. These big ones may form the nucleus around which galaxies form, but in any case, they're there and having some sort of impact on the galaxy that surrounds them. In addition, because these are regions of extreme gravity, regions of gravity that's so extreme that we cannot reproduce that here on Earth, we can use these environments as laboratories to study other things, other laws of nature, in a way that we wouldn't be able to anywhere else, certainly not on Earth in our laboratories. So we use the region around the black hole as a cosmic laboratory, and making observations like this that was produced by the Event Horizon Telescope allows us to study fundamental laws of physics, in a way that we wouldn't be able to do. So there's multiple approaches to this object that give us information about the object and about more broadly about our understanding of the universe.
Absolutely incredible. So one of the things I find absolutely fascinating is the fact, like you alluded to, that our supermassive black hole is so puny compared to others. The Andromeda Galaxy is a little bit larger than us, but it has a supermassive black hole more than 50 times larger. Why is Sagittarius A star, Sag A star, so small? Any ideas?
Well, we can speculate. We don't necessarily know the answer to that. I can give you some scenarios why that may be. These are a population of objects that have a range of masses. Now, the fundamental question about supermassive black holes is, number one, how do they form? How do they get so large? And certainly black holes can merge. And we see the stellar-sized black holes merging. We can't yet observe supermassive black holes merging, but we suspect that that's the case. So, you have galaxies that collide with each other, and their individual supermassive black holes find their ways to the center, the nucleus of the galaxies, and they merge and combine, and their mass grows. But, did they start out stellar size with 5 to 10 times the mass of the sun, and then over the eons grow into these big monsters? Did they form as big monsters to begin with in the very early days of the universe? We don't know that. So that's a big open question. And then number two, do they, again, as I said earlier, do they form the nucleus around which the galaxy grows, or does the galaxy come first? So does the supermassive come first and then the galaxy grows around it? Or does the galaxy come first and then the supermassive black hole builds up and falls to the center of the galaxy? We don't yet know the answer to that. New instruments coming online will help us understand that. The observatory behind me, the ALMA, the Atacama Large Millimeter Submillimeter Array, which was instrumental in this observation of Sag A star, is making observations of supermassive black holes in the very early universe. James Webb Space Telescope will help us understand this. So, we have these black holes that we don't know how they built up in size. Were they born that way, the way they are today? Probably to some extent, but they also increased in size over again, the age of the universe. Our black hole is indeed puny, compared to other black holes, supermassive black holes. And it's probably that it's feeding, absorbing mass and material and other things at a very low rate. And that is probably due to the dynamics of our galaxy, right? So we have these small satellite galaxies that occasionally fall into our galaxy and get consumed, as it were, by our galaxy. Those stars add to the Milky Way Galaxy's stellar component. The gas and dust that's inside of them might eventually find its way into the center of our galaxy and then fall onto Sag A star, causing it to increase in size. But I think the smallness of our supermassive black hole is an indicator that our galaxy has been relatively quiet in this regard over its history. Stuff falls into the center of the nucleus, feeds the supermassive black hole there, but at a very low rate. In other galaxies, that may be different. And so in other, maybe bigger galaxies, M87 that I mentioned earlier, that has a 6.5 billion solar mass black hole. That's a much, much larger galaxy. And one can imagine that based on the environment it's in, it's absorbing other companion galaxies, and their supermassive black holes are causing the big black hole in M87 to grow much more rapidly than our supermassive black hole. So I think that's probably what it is. It's just the history of our galaxy.
And some people, when this new image behind me came out, a lot of people who may not have been a lot of people thought, oh, geez, this image came out a couple of years ago, confusing it with the image in M87. But of course, Sag A star is much, much closer to us. So can you give us a little rundown on why it is we got images of one so far away compared to our local one first?
That's an excellent question. And number one, it's, to your point, they kind of look alike, right? Mm-hmm. And if we put them side by side, we can see some differences, and over time we'll see differences as well. But they look alike, and that is not surprising, because that's what theory is telling us, that these black holes should look alike. And so that observation in its own, you could look at that and say, well, it's boring. It doesn't look any different. They're identical. But that's really quite good, because it's confirming our understanding of black holes. They should look very similar. And in fact, they do. Now, more to your point, why these two particular black holes? And the answer is that these are incredibly difficult observations to make. In fact, these are some of the most difficult observations that humans have ever made astronomically. The black hole image behind you and M87 that came out a couple of years ago are the highest resolution images that humans have ever produced. And from a physical perspective, we're looking at an object that on the sky is 50 micro arc seconds, and an arc second is a measure of angle on the sky. And that may be meaningful, or more likely it's meaningless. It's kind of meaningless to me. I know what that means, but it's just a number. It's the equivalent of observing an orange or a donut, more or less the same size, on the surface of the moon. So if we put an orange on the surface of the moon and we sit back here on Earth with a telescope, we would be able to see, with the Event Horizon telescope, we would be able to see that orange on the surface of the moon. That's the equivalent of this observation of these black holes.
Wow.
M87, I'm sorry.
Yeah, yep.
Because you could ask why these two black holes, if every galaxy has a black hole. So they're very small, right? The black hole, Sagittarius A star, the black hole in our galaxy, is small massively in mass, but it's nearby. It's only 26,000 light years away. M87, on the other hand, is 55 million light years away, but it's much more massive, 6.5 billion times the mass of the sun. Interestingly, just based on how black holes, how big they are on the sky compared to their mass, that big, massive M87, even though it's further away, is almost exactly the same size on the sky as Sagittarius A star. And they are, in fact, large enough, both of those, that we can observe them with our instruments. We cannot yet observe other supermassive black holes because they're further away, they're smaller or whatever, but fundamentally they're smaller on the sky. And our technology, we're employing bleeding edge technology here to observe these two objects. That's what we can do today. Maybe in the future we'll be able to do more objects.
So we have a listener question for you. Devin from Brattleboro, Vermont would like to know, what is the ultimate fate of Sagittarius A star?
So Sagittarius A star is going to be sitting there in the middle of the Milky Way. Occasionally, a star or a gas cloud, a dust cloud, will wander too close. And by the way, these things are spatially small, right? So Sagittarius A star is about the size of our solar system, even though it's massive. Stuff that falls into the black hole needs to be very, very close. So, one question may be, what happens to us? Well, we're safe out here 26,000 light years away. But occasionally, stuff will wander by too close to Sagittarius A star, and it will fall in to the black hole, and the black hole's mass will increase. And so slowly over time, it will continue to increase. It's big enough that that's basically the future. It'll stay large for all intents and purposes, for the rest of time, if we have a universe that continues infinitely. Now, having said that, and you mentioned the Andromeda Galaxy, is a large galaxy that's near us, and both the Milky Way and the Andromeda Galaxy are falling towards each other. And some 4 or 5 billion years in the future, we will collide. And again, almost certainly our supermassive black hole, Sagittarius A star, and the black hole in the middle of the Andromeda Galaxy will merge and coalesce. And so the result then will be a much larger black hole. It will no longer be Sagittarius A star, I suppose, because we'll have a different galaxy after that event. But in fact, it will be a much larger object after the two have merged, and there will continue to be mergers. So some of our smaller companion galaxies will be absorbed by the Milky Way and by that product of the Milky Way and Andromeda Galaxy, and the black hole will continue to increase in size over time.
So interesting to think about. And finally, what are the next steps for you in astronomy and instruments to help study Sagittarius A star and other supermassive black holes? And how the heck does Webb come into this?
New instruments are coming online, new telescopes and new instruments that go in those telescopes. So they will allow us to observe the region around Sagittarius A star with better clarity. Stuff is moving and falling into the black hole, and so we hope to be able to observe that and get movies of the material swirling around the black hole as it falls in. We can study the stars that are orbiting the black hole. In fact, this led to a Nobel Prize. The study of the stars that are orbiting Sagittarius A star that allow us to understand relativity in a better way. And James Webb, because of its observations in the infrared part of the electromagnetic spectrum, will allow us to observe objects in the very early days of the universe. And some of those objects are going to be supermassive black holes in the galaxies that surround them. And so we'll be able to understand, again, that question that I brought up before, how do these big supermassive black holes form, and what happens to the galaxy that surrounds them. And so that, we're looking forward to that. And it's a golden age of astronomy, and I think we'll be going from strength to strength.
Fabulous. Well, thanks so much for doing this show, Joe. It was fabulous talking with you. And that was Joe Pesce, astrophysicist at National Science Foundation.
Thank you.
Galaxies are generally classified into 4 main types: spiral, elliptical, irregular, and my personal favorite, peculiar galaxies. I identify with those quite a bit, if I'm going to be honest. The Milky Way is considered to be a barred spiral galaxy, a spiral galaxy with, bars. That's the type made of stars and not, Milky Ways. We believe our own family of stars looks much like the barred spiral galaxy UGC 12158, nearly 400 million light years from home. Our local family of stars is ancient, first forming more than 13.5 billion years ago. This makes the Milky Way roughly 3 times older than the Earth and Sun, and not much younger than the universe itself. That means the Milky Way has been here a long, long time, but nothing lasts forever. More than 4 billion years from now, the Milky Way will collide with the Andromeda Galaxy, the big neighbor next door. This will merge the 2 galaxies together into a newly, oddly shaped mega-galaxy called Milkdromeda. Bear with us, it's a working title. We have billions of years before we need to commit to a name, okay? Join us next week on The Cosmic Companion as we take a look at robots in space. We're going to be talking with Jason McKenna. He is Director of Educational Strategy at VEX Robotics. Make sure to join us starting on the 14th of June.
Missing that episode would not compute.
I agree. Check out all of our episodes at thecosmiccompanion.tv or visit us at the Cosmic Companion anywhere online. Clear skies.